JDK tools about Java afterwards and more other things. I'm happy to see you, and let's dive into the talk. So about myself a little. I like working a lot with tools. I contributed to a book about DevOps tools for Java developers. And well, I like to combine most of the time working with Java and of course with infrastructure. So most of the time to actually make concepts that are not that well, I don't know, that I'm well aware of, let's say, about infrastructure, and transform them with Java if possible. Recently, I've been publishing something on my blog on how to build infrastructure with Pulumi, Java and Pulumi. And it's quite fun to actually build Kubernetes or virtual machines with Java nowadays and maintain that in a nice project, even with Java 21, instead of, like, I don't know, having a lot of YAML. But I still work with YAML as well, so that's nice too. Apart from that, I'm a developer advocate in the Java platform team at Oracle. And I enjoy to, of course, talk about Java, work with Java, and explore scenarios that are not so, I'd say, known or tackled because they are usually too difficult to look into. And in today's talk, we're going to look, of course, at what changed since Java 17 with JDK tools, what was brought new, because probably many of you are familiar with the 6-month release cadence when a new Java release, new Java version is coming every 6 months with changes, of course, and with features. Now, what you see here in the slide are mainly the JEPs, the features that come as JEP, but besides these, there are many more others that are actually enhancements, bug fixes, performance improvements that we don't necessarily see. And hence the talk of today that covers a little bit of the things that are not in the JEPs. And the goal of the talk, of course, let's look what's happened with the tools since 17 and major things that happened with the tools since 17. Now, first of all, let's look at the source and class file tool improvements. Now, probably many of you, since you're here, are familiar with the standard way of like compiling and launching a Java program. It's nothing new for you. You probably work most of the time in an IDE. You code Java. The IDE was looking into compiling that program for you, and then you can launch it from the IDE. But in the beginning, let's just say when we're learning Java, it's Java-C and then Java. And also with Java, we get some things for free. We call them standard compiler optimizations. These are not new, by the way. These haven't been in the compiler for a long, long time. The reason why I bring this up is because there's a change related to them. So among the things that come for free with the compiler is string concatenation, the one that is folded. So what happens is that when we concatenate strings in our code, that is automatically calculated, computed by the compiler. And of course, a lot of other good things like literal constants being folded, and of course, constants being inlined, and of course, dead code branches eliminated. These don't need any other flags, so you don't have to run Java-C with other flags to get these optimizations. But regarding string concatenation, that's something interesting that was going on with it. So before JDK 19, if we're looking at this piece of code, what do you think it outputs? And just shout anything. I know it's 8 p.m. almost, and I'm putting you to be a human compiler. Yes. But foo bar. Somebody said foo bar. Okay. Somebody else? Any other ideas? So we first build a string builder, and then we concatenate the builder plus the builder in append bar. True, but you never know. True, but this is just a simple example, and you don't want me to write the more complex thing and then tell you, so what does the code print at 7:30 p.m.? No. Brain overflow exception, that's another thing. Human brain overflow exception, it's another thing. So somebody said foo bar. Any other takes? Foo bar. Yeah, Yeah, it's actually foo bar, foo bar. And if we're looking at it, we're like, but you're first saying foo, and then we're appending, and how is this evaluated? So what happened is there was a bug in the invoke dynamic, and that was fixed with JDK 19. So what happens nowadays is that the same piece of code that we had earlier is evaluated, converted into a string in the left to right order. So it prints foo foo bar, as somebody said, and evaluated correctly, actually, according to JDK 21 that is nowadays and future JDKs. So this was a small bug, but it was fixed, and it's kind of important if you're having this kind of code at some point. Yeah, somebody said it's not going to be the case, but you never know how you get to this kind of thing. And you're asking, what? I was expecting foo foo bar, and it's not happening. So yeah, this was it was a bug in the invoke dynamic-based string concatenation strategy introduced by JEP 280. But it was fixed. And if you're interested in the fix and how did this happen, it's in the string concatenation of order operation, and that's the link to the JDK fix that came with it. So it's not collected from nowhere. You have all the details there and why this decision was taken on concatenating strings like this. Now another question maybe for tonight. Warnings on lossy conversions. Now, if you're to write this code, and please make extraction of the fact that, yeah, you could rewrite this and so on. We're going to look at the rewriting part as well in a few seconds. So if we are to write this code, if we're doing this kind of computation, you are getting, of course, an incompatible type error. So you get the fact that you got a warning, more than a warning, you get an error, that you're going to lose something if you're trying to do this kind of conversion from double to long, right, in this case. So this is a great thing. However, if I am to rewrite the same piece of code with distinct operations, like this is no problem before JDK 20. You can try it. It's really fun. So if you're trying to use the operators that is plus and equals or minus equals operator, or all these kind of operators, this error doesn't occur before JDK 20. After JDK 20, this is going to be actually flagged as a warning because it's a lossy conversion. And you get this flagged by the compiler, so it's not escaped anymore. One other interesting thing about the lossy conversions, and why this change was done now, is because, well, besides these warnings on the conversions, which are important for applications that work with large computations as well, some people realized that if you're writing this kind of code, it works. Some of you are going to say, like, okay, but this is not a good practice. Indeed, this is not a good practice. You shouldn't call overridable methods from a constructor. Nobody does this, right? 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 But the thing is that some people, okay. Sorry about this. Something came up on my computer. So the thing is that this was a very, very good code. And what happened is that in JDK 21, the compiler gets a new escape key for linting this kind of situations and tell you that's not okay to do. Because that's actually a not okay practice to do in your code. So before JDK 21, you could call the hash code from the constructor, but you are getting away with that. Now you are getting a warning on this. So that's another important change that happened to writing better code, actually, and avoid bad practices. But I think the most important changes that came to the tools were about enhanced usability. Now, since JDK 11, we have single file execution. So we can write Java classes, and we can say Java Hello World Java, or just have it launched without saying Java C anymore. You just say Java Hello World Java and it runs. But besides launching Java application easier, In JDK 22, what JEP 458 is proposing is to run a program, a Java program that is supplied as multiple Java files to be ran just with one single command. So just imagine that we would have something more complex. You could just write java minus class path everything and say hello world Java. So in this case, it will look into this and just run it without, going and saying every dependency in part, and have more into looking into it just to run the program itself. So this is a pretty cool enhancement regarding the launcher that is coming in JDK 22. Apart from the launcher and the javac, I promise that I am done with the compiler questions for tonight. Another one will come, but on something else. We're thinking, of course, about writing API documentations. And in order to generate great API documentations, we had several ways of doing that until now. Of course, the tool that we're going to look into is Javadoc, and what happened to Javadoc and what Javadoc has in support to writing even better API documentations. Now, the goals of API documentations, just in my opinion, I think that overall they help you with what you're maintaining, with the API that you're writing. Is usually easier for people to understand the goals of the API that you're building, and sometimes can increase even the awareness of your software. I think you're pretty much aware that you're most of the time choosing libraries or software that have good documentation, right? So you're not going with something that is poorly documented, because that means that you cannot trust how that thing was built. So good documentation is essential for good APIs. But words, they're easy to write. If you are to write examples, then those require extra care. What I'm trying to say here is that most of the time when you're writing API documentation, you're also saying, hey, if you want to invoke this endpoint, you can use this type of request. And you can give an example, right? And for writing that kind of example, you have several ways to do it. So first of all, what happened in the past, and now how I have done it, was to write code examples using pre and at code. And I was doing that because, well, with at code, I was kind of automatically escaping these special characters. The only thing that I realized is that I have little control over indentation, and also I have no way of highlighting something in the code examples that I was giving for my APIs. And to give you an example of something that is similar to an API that I wrote more than 10 years ago, so more than 10 years ago, I created an API that was SOAP API. And this is like a random example, like could be from a SOAP API. So imagine this, that you want to say how you can use the user type of the API, and you want to give that as an example. So you're writing some XML, right? With parent code, it will look like this. Some XML just put here, saying the complex type, the context, what restrictions are there, and so on. And the output, if you're just running Javadoc on it, would be something like this. Java class for user complex type, and so on. Of course, it shows a nice XML and other parts, but doesn't have anything that can say to the user on what they should focus on. Maybe on the element name, or maybe other constraints like for min occurs, max occurs, and so on. So in order to support a better inclusion of code examples, JEP 413 introduced a snippet tag in JDK 18. This JEP had also an influence on how Javadoc tool was working as well. So by enabling snippets, you get a better presentation of your code examples. But moreover, you can also have control over the code via a few tags, like highlight for highlighting some important parts of your code, replace maybe some parts of that, or link to other pieces of code. But you also have a way to say highlight specific regions, replace specific regions, or link to specific regions. That's very important. So if we are to look again at how that previous XML would look like, or that previous Javadoc would look like, with that snippet now, We have, first of all, we have the tag at snippet, and I can specify also the language. So a snippet supports several languages. You can say, hey, this is using XML here, or any other type that you're saying there. This is great because you're kind of saying what's the indentation expectation for what you're writing here. Secondly, as I said earlier, I can define regions by names, like in the case region element, and say, hey, I want to highlight this region element, but moreover, I don't want to highlight the entire element that I see here. I just want to highlight the name, because the name, the value of the name, it's what I find important. And that's something that my end users, my technical users, should look into. So what I just used, a regular expression for name and the word that is coming after it. And that's a very sleek way to control how this will be output. And if we are to look at the output of this, now we have, of course, code and the name bolded. So I said, hey, highlight for me with bold the name and its value. So I can see as a user what's important, these in my user. But that's an interesting change. Another great thing about this tag is that you can specify all that XML if it becomes too complex, because sometimes when you're writing SOAP APIs, you have complex types depending on other complex types with other constraints. It can get to a very long XML. So maybe it's better to isolate that in a separate XML file that you can validate yourself, that you can use in your tests, by the way, so you can have a control of what you're writing there. So what this tag is doing is that it accepts separate files that contain the content of that snippet. And moreover, if you are to run javadoc, you can do that by specifying the snippet path, the path to that XML that you extracted. So in this case, -- snippet path.source XML, and of course, the user.java being my class. It's not just for XMLs, by the way. The snippet path works for any kind of code examples that you want to give for your code. It's a better way to just keep in, the concerns, let's say, separate, and to make sure that you're also testing the code that you're saying to your end users. Because, for example, if your API changes and you have tests for your API, it's great also to apply some of those tests on the code that you're having for those snippet examples. And this way you keep everything in peace. And also, the previous javadoc simplifies a little more and looks something like this. So now you have a snippet file, and you can say just the file user.xml, and of course the language, in this case, is XML. And you get the same results when you're running javadoc with that. So this is a very nice way to keep things more structured, easy to test, but also to get more control over your documentation. Also for documentation and for javadoc, yeah?
If you want to include this snippet in Java,
yes.
Can you use also the separate file like that?
Sorry?
Can you also use a separate file like that if you want to include Java code?
Like to specify Java code in a file, and I think you can. I haven't tried it, but it should work. It's just another piece of code. I thought that XML would be much more real life. But yeah, I think there are a range of language.
You can, because I've used it in a unit test.
Oh yeah.
And I used the code of the unit test, or portion of the code of the unit test to inject into the snippets.
Okay, so you have the real world example. Yeah, I haven't tried it with Java. I tried it with XML, with whatever else I tried with.
No, with the regions you can define.
Yeah, so you, as Olivia says, you can define the region, and yeah, you can include that. It's pretty useful. I think people give sometimes JSON examples. I don't know, whatever the APIs are relevant nowadays. But yeah, also works with Java. I think you have to specify lang Java so that it indents and formats for Java. That's the only thing. Another thing for the documentation is interactive documentation. Now, if you're going to javadoc documentation, it will tell you that the tool supports CSS, which means that you can customize the look of your application. But you can also add script files, meaning you can add JavaScript to your documentation with the --add script option of Javadoc. This is also new that came to Javadoc. And you can just give, like, for example, in this case, interact.js that says an alert okie dokie. What this will do, it will add the script interact.js to every file that you're running Javadoc on. So now in this case, it's just user.java, but I could have more Java classes, and what we'll do, it will add a script tag to each of my documented classes with that specific interact.js. If you have a page that serves only a redirect to other pages in your Javadoc, that will not be affected. So that one will not have the script tag, by the way. So this one applies only for Javadoc pages itself that describe something, not for redirections. And it's pretty cool as well to, be a little bit more interactive in your documentation. Any questions so far? Besides if it works with Java? You can also use this one to add multiple scripts, so it just doesn't work just with one script. It says --add script, but you can add more JavaScript files to that one, and it will work. And of course, that's the change documented there. The next part that I want to go to is the development and deployment tools, which probably you're using more because, well, they're handy in the daily developer life. Now, they serve different purposes, but they all are having the scope to improve the way that you code. The first one I mentioned a little earlier is JShell. Have you used JShell so far? Okay, good. So it's great because we can debug quickly some small lines of Java, and we get feedback, and it's pretty cool on that. But what JShell didn't have was a way to highlight the deprecated elements. So what happened is that starting with JDK 19, JShell highlights deprecated elements, variables, or keywords. So like in this case, you'll get a warning, but you'll also get a way to see what exactly has been deprecated. That was not before JDK 19. That's the change documented. Apart from this, which is more visually in helping you, JShell, historically speaking, supports loading scripts. So JShell is not just for interactive exploration of Java code, has also been enhanced with predefined scripts to be run. So you can run these scripts to help you in your Java prototyping. While the scripts default Java SE and printing were before JDK 17, tooling script was added in JDK 21 to support loading a few JDK tools and work with them directly in JShell. Now, this is really cool, and I'm going to demo in a bit. When you start JShell, it's easy. You just say JShell tooling, so you can specify that you want to run the tooling script right from the beginning. Or if you just open a file and you're editing it with JShell, or you are doing some operations on it, you just can say later open tooling. When you say open tooling, you're loading that script, and you have a way to look into its available tools by saying tools and invoking that a method there. But also you can execute a tool in command line JShell session like javac and others. And this is the change where it's documented. Now let's see that a little bit in action. I'm going to take a little sit here, hopefully. Going to the IDE. Oh, I have the wrong project. Okay, now it's better. Okay, so let's use a little bit the JShell. So Java 21 first of all. I'm going to just say touch example.java. Use a little bit of a new feature of JDK 21 in preview, and say var check new boolean true. the one that we had earlier, right? So let's go and say example.java and load this in JShell. Of course, as I said earlier, you can see that it highlights the fact that I'm using a deprecated feature there. So I open this one, but I want to use the tooling. So just say open tooling and say tools, just to see what tools are available. So I can use in JShell directly jar, javac, javadoc, javap, jdeps, jlink, jmod, and jpackage, which is pretty cool. But how do I invoke them, right? I don't know by heart. Let's say I don't know by heart what I showed earlier in the slide. I can do this and say edit. And what happens is that I get the JShell edit pad, where I get both my code that I wrote earlier, but also helpers on how I can invoke those tools. So for example, I can invoke jar or javac by saying javac and arguments on how I would invoke javac in the command line, like said there, or use, like in the slide, run javac and arguments coming after that one. So this is the way how you can find out how to invoke those new tools in JShell there. Okay, so I'm going to say accept, say cancel, going back here. So let's run a little bit javac. So it said there that I can invoke directly javac by saying a number of arguments. So I'm going to start with example.java. I'm using a preview feature, right? So I'm going to say ---- enable preview. It would be good to say a source, ---- source, and of course a version for that source. So what this one did, it said, okay, like earlier, it said the warning, but also says that example.java uses preview features of Java 21 and recompiled with excellent preview for details, blah, blah, blah. And the result, of course, an example class here in my IDE. Now, this is just a simple example of using the tooling. There are much more that you can do with others, with JDEPs. I haven't tried jpackage in JShell because I didn't find yet a way to apply that. That would make sense, actually, to try like that. But it's pretty cool to use that directly in JShell. So let's exit for a moment. Okay, let me go back to the presentation. Where was that? Okay, good. So that was for the tooling script. But now I have another question for you. Now, earlier you've been a little bit of compilers. Let's talk about what would you do in this case? What would you use for local prototyping, testing, or debugging a client-server setup? This is a question I'm asking tonight. Docker. That has been said before. Docker is very much preferred for that. So there's Docker. Docker Compose. That's very good too. I've used it recently. Test containers, very good. People are thinking very complex setups. What else? No, it's all good. Yes. Yeah, well, but that's why we're here tonight, right? We gathered here for that. Yeah. Yes. So all three options were good. But sometimes, for like simple situations, you can use JWeb Server. That was introduced in JDK 18. So there was a new JDK tool introduced in JDK 18 that can help you with what I asked here in this question. And let's look at it. At some use cases. First of all, this is great because what JWeb Server can do for you is to serve a minimal web server to like give you static files only. So you don't need like make a new CGI or I don't know server-like functionality and something complicated. It's great for web development testing. So when you like need to simulate locally a client-server setup, you just run JWeb Server and it's just working. Secondly, it is great when you need to like stub static files to like show an API, how an API would work for web service prototyping or application testing. And this is a real life use case, because back in the day, when, let's say, my team was, one of my teams was separated in front end and back end, and used to be like back end folks used to make an API, but also front end folks were using with the same API. We had to work in the same time. We used to have a service called Sandbox, where we could prototype together that and work together on that. So that was like a third-party service. It was nice, but it required an extra hoop to actually maintain and look into, and to like tell people, this is the sandbox, this is how it's looking like, this is how you have to use it, and so on. Now with this one, it's way easier to prototype and just run a JWeb server somewhere with some static JSONs, and just people just go there, put JSONs, and JWeb server is serving them. Because that's actually the last case where you can search a directory in a remote server from your local machine. So for example, you have it somewhere started. You can, with some serving you some static files that you copy paste all the time through FTP or something like this. You can just serve it with JWeb server. And of course, it's great for learning as well. But apart from being a great JDK tool for all those cases, and you can introduce that in your tool chain, it comes with an API. So there is a simple web server API that you can instrument programmatically, and you can control how the JWeb server or the simple web file server that you're building will be behaving. There are a few things documented there in the JWeb server on Inside Java about JWeb server, but also on dev.java, and the links are provided at the end of the presentation. But I want to show you how the simple file server implementation looks like for stubbing an API. So I'm going to take a little sit again, go to the IDE somewhere here. Okay, so the memory server, it's a simple file server application. The code is online already. It's in the last link, so it's from dev.java. It's nothing that's not provided. So what this code does is using the simple file server to create a neat memory file structure and to serve, well, in this case, JSONs. So what I'm doing here, I'm first creating a directory path, which is in memory. I'm using gmfs library for that. And then I'm creating the file server with a simple file server API by saying what would be the address. So in my case, it's going to be localhost. And of course, set the executors for the server and then start it. So how does the directory path look like? Well, as I said earlier, I'm just creating an in-memory file system with gmfs library, starting from some root directory that I can customize. So it's something customizable depending on how your API looks like. And of course, I'm needing some JSON. So for that, I use string templates just to give a way of processing JSONs. Now for string templates, that's another preview feature. So we're going to see how we can handle that throughout the life cycle of this application. For the moment, just running this in memory and go to the browser, localhost 8080, it's just going to create some fake paths to some directories, in this case, something.json, and prototype that with some values of its choice. So now there's other paths and so on. Can make it more complex and make them even more interesting API stubbing and have this programmatically controlled. So this is another way of using JWeb server and customizing your setups and your ways of working. Yes?
The content type that is served, it's based on the extension of the file that is served?
Sorry?
The content type here, we saw that it's application JSON. It's deduced from the extension of the file?
Yes.
Okay.
In my case, yes. I think in this case was dependent on the library that I was using.
Okay.
because I've used without the library, but using file statically and not saying anything, it was interpreting it, so it had no problem. But I've used this in memory generation of things because I didn't want to create anything on my machine. So this is just in memory way doing. But yes, based on the extension, it knows that it should be a JSON rendered there. So that's one way of working with it. Now we're going to come back to this application a little in the presentation because we're not done with it. So that's the simple web server API. Now, let's talk about packaging self-contained Java applications. So recently I saw a debate that somebody was angry that they didn't have an executable to install an application and they were getting the source code. So they were very angry that, hey, why do you give me the source code when I'm not getting an executable? I need an executable. So to address that kind of issue, you can package self-contained Java applications with JPackage. Now, JPackage is not a new tool that came after JDK 17. It's older than JDK 17, it's 16. But it has some nice capabilities. So what is nice about self-contained applications is that you can package that application in a platform-specific installable package, like the user was demanding an executable like a .exe if you're running on Windows, a DMG if you're running on Mac, or I don't know, something that is specific to any other operating system that is for Linux for installation and so on. So you can simplify distribution in that case. Now, JPackage is great, but it's not just great for distributing applications that are platform specific. It's also great because for modular applications, JPackage can automatically run glink on them and generate a runtime with only the modules needed. So it runs glink under the hood if you have modules defined. Why I put this specifically in the slide here is because I've seen some examples over the internet for modular applications where some people are running first glink and then are running JPackage. And I did this because, well, you don't need to run that extra hoop if you already have a module info.java defined for your application, and then you run JPackage. So until JDK 19, installing a JPackaged application was something considered to be system-wide. So that was happening because the startup parameters for that application when you were installing it was considered that is a system-wide installation. But the thing is that some folks said, well, we sometimes need things depending on users or parameters. If you are to look at how you're at using JPackage, if you're running a JPackage command on a simple jar file, and we're going to do that in a moment, the output in this case when you're running this command will be a jdemoapp.app for the type image. So what the type image is doing is creating an application launcher specific to your operating system. I have a Mac, so it created an application launcher for my Mac in this case. But also it has some resources regarding my application. Can be icons that my application is using, can be configuration. The configuration info is made by JPackage, and of course the jar file that I had earlier is copied at the runtime. But the thing is, before JDK 19, all the time when you were starting this one, it was all the time looking at the JDemo app configuration. So it was the configuration info made by JPackage, thinking that all the time it has system-wide privileges. But as we know, we're not most of the time working with system-wide privileges when we're installing applications. We're working with users and specific user parameters. So we have config files with specific user requirements, right? So what happened is that after JDK 19, the application launcher will look for the config file in some user-specific directories. So you have here all the types of directories depending on operating system, and I also placed what the package name means and so on. So how is going to be the installation thought of? So how is the .cfg file looked into? How are the ways to look into it? First of all, application launcher will look for a .cfg file in user-specific directories, the ones from the previous slide. If there's no specific user, there's no CFG in the user-specific directories, then the installation directory is going to be the one called from the installation. So it's where you are, saying I'm installing this application here, is going to search for a .cfg file there. Now, if you are running the application from the application image directory, like I showed you earlier, that Mac OS is going to look for the application launcher executed from that location. So this .cfg that is closer to it in the demo app. So that's the third. So this one became the third option that used to be before. Let me show you how that looks like for a simple jar. So, sorry about this. Let's go to this one back. And go to Tools. Oh, come on, Terminal. Yeah, great. So let me clear this. Okay, so I have my memory server. Let me just do a mvn clean package to create a jar for it. Okay. So using jpackage, if I want to package my jar, I have to give it first a name, and I'm going to say memo, like in memory server API. Say an input, like in my previous command, it's going to be from target, where my jar is, of course. It's going to be main jar, which is going to be memory server, memory server.jar. Let's put some space here. Main class. So I want to know when I'm starting this jar, what's the main class that I'm going to use. So I'm going to use the in-memory server. So org.example.inMemory file server, not .java, in-memory file server, sorry. And of course, I need to say a type for it, which is app image. It's not going to make it specific to Mac like .dmg. I'm just going to say, hey, make an application image. And of course, because I was using string templates, which are pretty much a preview feature, I have to give some Java options. So I'm going to say -- enable preview here for my application. And let's see, hopefully I managed to write the correct command for it doing this. Okay, hopefully it created my app. Yeah. So it created my memo app here, which uses preview features. And you can see that it was pretty much the structure that we saw earlier in the slides with a few less stuff. So I have the application directory here with classes and everything that was generated before. The macOS image, of course, runtime information, package info pillars, and of course, other things. So if I'm going to go now to memo and open it in terminal, I can run this nice image. By the way, I hope I stopped my server earlier. And say .memo. So now my application started on 8080 as well. What this means is that when you're making a type image, of course, if you're building on macOS, it will generate an image that is runnable from macOS. It's still platform specific. But imagine that you're doing this on Linux. You can run this on another server, and you just can deploy it easier and just start it like this with a point and slash in there. And now I have access to the local host again, and of course, listing some information for my server. So I can package this and distribute this anywhere, simply like that. Another use case for this is for JavaFX applications. So most of the time, so JavaFX can be ran as a runtime, of course. You can create JavaFX applications with JavaFX runtime, or you can use the JavaFX JMods. Java itself is coming with JMods. So because when Java moved to modules, it can be also be distributed as JMods, as modules, so it's module files. That's another way to build and distribute applications using JMods, especially for modular applications. That's a very, very reasonable way to do it. But I've seen most of the time people using JMod and JPackage for JavaFX apps, just to keep them as tiny as possible and have control of all the modules that are used there as well. Any questions so far? Okay, so we're going to go to the next part, the security tools. There are a few enhancements that came to the security tools as well. Well, this one, since JDK 18, you can have a version. You can check the version of key tool and jar signer. So for example, you have a key tool or a jar signer on some kind of a server. You don't know to which jar version they belong to or how they were put there. You can now check with -version. Apart from this, there are some updated options for key tools. So for example, you can get a warning when you use weak password-based encryption algorithms using the -gensec key option and when using -import pass options. So they're now updated to warn you on weak PBE algorithms. Oh, sorry. This is an example, and the way that they do this is by looking at the key algorithm. In this case, they look at the key algorithm, they realize that arc4 it's not a safe one. So the generated message is like, hey, you get a warning because you're trying to use a secret key with a vulnerable algorithm. Apart from this, there are a new option for jar signer for specifying the provider, the class path to a provider with -provider path, like in this example here. So for example, you have another key store type, but you need to like say, hey, this key store is coming with this provider that's external to the JDK. You can just give the -provider path option and specify that. -provider class was there before. This is just new to help the -provider class part as well. And of course, there are some removals. -alt signer and -alt signer path have been removed in JDK 21. So if there's any tool chain that uses them, yeah, starting with JDK 21, that's not available anymore. And all the changes regarding the -provider path is listed in there in the JDK change. Let's go to the last part for monitoring tools. Now, regarding monitoring tools, I like to make a little amendment before I go into them. So some technologies and their goals. First of all, GFR, JDK Flight Recorder, is with the scope of collecting, diagnosing, and profiling your Java applications. That's its scope, right? So it's for profiling applications. If you need to have a continuous consumption of what's going on with your data, and you can look at the GFR data on the disk by using GFR Event Streaming API. And last but not least, if you want to have GFR plus other parts and other ways to monitor and manage and profile your application, you can use JDK Mission Control. I know JDK Mission Control looks like a single tool. Well, it's one executable that you install, but it has multiple tools inside it and multiple capabilities. Probably the most important change that came to GFR was the new command for GFR view. So this new command is great for inspecting what's going on with your data, and you can profile your application and get aggregated event data without going to JDK Mission Control. So the way to use it, first of all, you start the start flight recording, like in this case with the -XX start flight recording. And then you can use the PID or the jar name in the GFR view command, or use, in this case, JPS tool to find out the LMVM ID. Sorry, damn, too much, sorry. This is an example on how to use the GFR view command. But let's look at it a little bit ourselves in practice. So let's go back to the IDE. So how do you want to use it? You want to use it with JFR view with the LLVM ID, meaning the PID, or with the jar name? Which one? PID? Okay, fine. With PID, I need a little change in. No. I'm going to explain why a different change. No, sorry. I'm going to use a J package again. But as I need to start the flight recording when I'm starting my application, and it's XX, start flight recording. And should be this. Oh, no, not minus XX. Damn it. Only one minus. Damn it. I was in a hurry and I put too many minuses to it. Okay. Okay, so this one is created a memo app. Of course, it's not going to take care of that one anymore. Let's go to terminal. Start memo. Okay, so now my application starts with JFR, right? It's on. We said we want to use JFR view with a PID. JPS to find out my PID, which is 96376. That's the PID associated to that. And clear, sorry, go here. JCMD PID and JFR view. Not hot methods, let's say GC pauses. So what I asked here is like, give me a preview of the GC pauses that happened with this PID here. There are also commands to restrict this and to like have like a max age or a max pause in what you're having, in what you're seeing there. So there are ways to get only information for what happened in the last 2 minutes, for example, or to restrict how much of the data you see here. But it's pretty much easier to just go here instead of just going directly to JMC and watch the information. And of course, the one that we saw earlier was hot methods, but I expect no method to see here. Yeah, there's no methods that execute the most because I need this. I need to do some actions to actually see some hot methods. Damn. Yeah, the thing is that if nothing is happening with the application, it's stalling, it's not going to be something seen. There's no events for Java methods that execute the most. There's nothing that could be relevant for it. But yeah, that's one way to do it. There are a series of events. There's a series of views that you can aggregate, and they're all documented and provided, and how you can see more of that. So it's pretty cool to just see what happened with your application without going to JDK mission control. This was one of the major changes there. So hot methods, by the way, are the methods that, of course, execute the most, like what you saw earlier. So in this case, for the example that was here with the jar, these three were executed the most for the jar that I was having. But apart from this, and looking at GFR view and inspecting what happened with the events for your application and have that all together, there are new events, of course, that were available with after JDK 17. So one of those is the JDK finalizer statistics. That is, of course, identifies classes at runtime that use finalizers. Now, if you are starting Java minus finalization disabled, so if you start with finalization disabled, this event will not catch something. So if you're doing this, you're not going to see anything in it, even though you are having that enabled by default, just something that you would have to be aware of. is enabled by default in the profiles, in the default and the profile.jfc JFR configuration files, so you don't need to go and enable it yourself. That's the good part of it. But if you don't like it and you want to disable it, I've given you the commands on how to do that. So you can do that either with JFR configure and say JDK find ladder statistics DS and enable false, or you're doing it from the -XX start flight recording and you say from the settings, how do you want that to be disabled? That's the two ways to disable it right there. Another property that was brought after 17 was a cryptographic event to see the initial security properties. Now, these are good to be seen, like to understand how were the initial security properties when your application started, and maybe throughout your application lifecycle, some of those properties are altered. So you can have like a starting point and compare later on how that changed. There is another cryptographic event that captures the changes on the security properties, but there was none for looking into the initial security properties. Now, this one is also enabled by default, but you can disable it with the two commands there. And of course, you can record details about your security providers and to understand what security providers your application is using by using the event JDK Security Provider Service. Now, this one is disabled by default, but you can enable it with the two commands from here and inspect it. So it's pretty easy to do it like that. These are pretty nice to be seen in JMC, and if you have patience with me, I'm going to run JMC in a moment to look into those. And speaking of JDK Mission Control, there are a few changes to it as well. So first of all, the graph view is updated to allow a limited number of nodes that are displayed. Now, graph view is actually very useful when you're looking in JDK Mission Control. You have stack trace. You can see the stack trace for different, let's say in case of method profiling, you can see the stack trace that were specific to that method that you selected. But you can also see the graph view of how the invocation to that specific method came through in the graph view mode, and you can now select how many nodes you want to see there. And it's very nice to like go more in depth or less in depth to look into how the invocation happened there. And this is a simple way on how to get there. So what I shared earlier in the example use case for method profiling, and like if you're going to method profiling and let's say select hash map, put map entries, you can go to graph view and you can select how in-depth or not you want to see the samples that are in your recording for that specific method. And by the way, if you want to like go more, you just have to click on a specific one and it zooms in, just in case that you were wondering. Flame view graphs, they also got a little change. You can also limit the data in the display view by using the samples dropdown. So for example, if you're opening a JFR recording, you can go to memory, you can go and see a flame view, but you can also visualize where your program is spending more memory by, so for example, looking at sample weight, TLAB size, or allocation size. So this is how you can find the view, like I said earlier. And of course, a new dependency view. So there's a new dependency view with a chord diagram where you can see a graph with thicker lines for dependencies that are having stronger connections. Like for example, you have more connections to a specific module or specific package, you're going to see stronger connections in the chord diagram. And that's a way, like if you want to visualize the chord diagram, because it doesn't appear in all the views. For example, for memory, if you're selecting a class in your memory, then you can see the dependency view and then go and see the chord diagram. Like for example, this. So if I'm going to memory and let's say I'm selecting object. Yeah, it's a lot of dependencies, right? So you can see here the whole entire dependencies. You can see that's a heavier dependency to Java I/O, but also to, of course, RMI transport, some JMX, Java Lang a little bit, and others. So you can see a nice diagram. And these arcs connect data point and indicate all the dependencies that you have there. Apart from this, let's go and watch it a bit. Okay. It's interesting with the subway nearby. Okay. So let's start an application. I'm just going to kill this one because I want to start memory server differently and say java minus jar, no, minus enable preview, I think, minus jar, target, what was that, memory server.jar. Yes. So I wanted to start it without the flight recorder on because in JDK Mission Control, I can create a recording without needing to have the flight recording enabled. What do I need? Memory server, this is the one. Start a flight recording. And if I'm going to go here, I'm going to go to the template manager. This was my last template that has all the previous discussed events enabled. So I'm expecting to record a few things. Then I'm going to say next. And I can search for security to check how are the security events that I talked about earlier. So we talked about initial security property. This is enabled by default. But also I enabled the security property modification, like to see if something changed on that. And of course, the security instance request, I changed it to be enabled by default as well. And to all of them, threshold is 0 nanoseconds. So I really want to capture everything. If I want to omit something, I would set the threshold a little higher. So let's do a finish and wait for 1 minute for a recording to be done. Yeah. So this is the way that you can, by the way, connect to running JVMs that you're not necessarily having on your local. In this case, they're both on my local. But you can have JVMs running to different locations, and you can connect on JMX to them via JDK Mission Control. Not necessarily having the flight recorder on, but you can use JMX to connect to them and do your own recording. Because I doubt that, secured applications would have ports that should allow you to connect directly to them on 8080, for example, and do recordings. But JMX is always a safe way to do it via user password and so on. So 91%, and now I'm waiting for the recording to be done. Okay, good. So I got a nice recording. If I want to go, first of all, to the event browser to check on my events that I talked about earlier. So I had the security request. There is the initial security property. And I can see here that I have a few things about, of course, the security provider Apple, because I'm running on an Apple machine. Where's the security policy and how I'm running everything. So, and also which security provider was preferred first, then the second, the third, and so on. Algorithms and other things. Now, if something would change throughout the life cycle of my application, doesn't happen now, but if I would change a security property, it would appear here and be registered here. Now, security provider instance request was just one, because probably the application was that one, the security provider was invoked only once when the application started. And in my case, it's the Sun security provider. And if we're looking down here, you can already see some flame graphs. Well, it's not exactly flame graph, is the cool version. This is the flame graph. And of course, it doesn't have samples like in the case that I showed earlier for the flame graphs. Now, for the flame view, if we want to see the samples that I talked about earlier, we can go, to, as I said, to memory. And we have sample weight in case of memory for the object. For example, for the graph view, let's say method profiling, just connecting array list. by default it selects, okay, the 41 nodes. But if I want to simplify this, I can just go to 10. And as I said earlier, you can just double click and it will zoom into the specific node and the specific sample just to see which method was there invoked. Because it's tough like to look at it from here and not just, you know, double click to have a closer look to what happened there. Now the graph view, as I said, is easier to navigate and to look in the connection between different methods that are invoked. And from my point of view, it can be a similar view like from stack tracing. When you're going to the stack trace and you're looking into the stack trace and you're just choosing the next frame group to navigate between the connection, between every connection that happens between the methods. It really gives a nicer view about the connections there compared to the stack trace. Yeah, and of course, dependency view. As said earlier, if I'm going on memory, I can see the dependency view for object in my case, but if I'm moving to array list, it will be a different one. And of course, there's like the chord diagram, but also there's the edge bundling diagram. So you can like see just the lines with the connections, and if you click on each of them, you can see the packages and the connection between the packages and the lines there. Personally, I prefer this one more because it's more colorful and so on. But it's just my preference, and of course you can select the package depth for it. So for example, you can like go up or and say a bigger package depth to see more details. You saw that there is a JavaLang invoke, but if I'm going to less, let's say to 2, I just see JavaLang, more generic. So you can go into more in depth to see what exactly the dependency is. Okay. Where you can find out more. So you can find out more on dev.java. Some of the links that I'm going to share next are from dev.java. There are tutorials on the JDK tools, all the JDK tools there. There are other useful materials on the JDK tools and not only on inside.java. We keep that updated with events, with interesting talks from different conferences where engineering team or us have been and talked about different aspects of Java and what's going on in Java. But something I want to draw your attention to is that on dev.java you can contribute yourselves. So we're welcoming community contributions to dev.java. We are welcoming your expertise in Java so that you can help others learn it and do it better. So yeah, I have a repo which I can give to you and share with you where you can contribute with content. And of course, we have youtube.com/Java with videos on what's going on new in Java, but also with helpful tutorials like on how you can use certain JEPs, like the JEP Cafe in practice, or videos from different conferences or other aspects of Java like JDK security that you can learn from. Of course, the useful links that I was talking about, because there are a lot of articles that describe examples with using the JShell API or either using the JShell tooling. So there are all there. And also how to package a JavaFX application with JPackage if you are interested in that, or how you can use JWeb Server programmatically and in more advanced usage with like 3 or 4 cases on inside Java. So all of that is there. But also on how you can monitor Java application security with JFR events and JDK tools. So all these tutorials are written in there. And last but not least, this is where you can find the slides so that you don't need to take pictures of the last one that I shared. And yeah, and scan this one. So yeah, and now we can talk more about Java, or we can go for a drink and talk more about Java, yeah, our tools. Thank you. Yes.
I just had one question about the GFR events, about enabling them or not enabling them. What would be the rationale or use case for selecting to want to limit some of those? Is it because they had some overheads to the?
I don't know So I know that there's like a general saying about the overhead that GFR has in general, but maybe you don't want to record all the events because you might not find them useful for your monitoring parts. So for example, regarding, let's say the JDK, the ones that are related to security. For example, for the TLS handshake, I think that that one is not enabled by default. The reason being is because maybe you're not interested to look into those details. I think the most important detail on the TLS handshake one would be the duration. But most of the time, the duration of a TLS handshake is so fast that it's actually 0. So you can record them, you can stream them, but you're going to get a lot of zeros. Of course, you can also enable them and then, let's say, set another threshold, because you saw in my template, I always set threshold on 0. But if you want to make sure that you're capturing only events that have a longer duration, you just set the threshold higher, and then you just capture the events that you are interested in and that would draw your attention. Yeah.